solving this Olympiad question, x, y equals to 20, yz equals to 30, xz equals to 40. We are to find whatever the value of x, y, and z is. We just have to find x squared plus y minus z equals to what? For the further, we have three equations. We need to number that so that we can easily identify each one of them. So we say this is equation 1, then we say this is equation 2, then we say this is equation 3. What I have seen quite a number of people doing with this kind of question is using substitution in order to get the value of each variable, which is not going to work here. If someone is saying we're going to make x subject the formula here from equation 1 by saying x is just equal to 20 over y, and you are thinking you're going to substitute that into equation 3 by saying, okay, we have x here, so instead of having x here, we can simply say 20 over y, which is x, then z, this x is this, so we've written that, then z here, then equals to 40. This is more or less like coming back to the same point, because what you don't know here is remaining two variables, the z, the y, and this is just a complex kind of step which is not heading to anywhere. Therefore, you don't want to do this way. And the brilliant step we're going to take in solving this, let's say step 1, we need to multiply the three equations. Yeah, that is equation 1 multiplied by equation 2, then multiplied by equation 3. And we have x, y multiplied by y, z, then also multiplied by x, z. I can vividly say this is equal to my xy is just 20, that is, I have 20 here, multiplied by, then my yz, that is 30, I have 30 here, then multiplied by my xz, that is my xz here, is just the same thing as 40, so I put 40 here. If I can break down this left hand side so that I can really see what it actually means, multiply by y, multiply by y, multiply by z, then multiply by x, multiply by another z, equals to 20 times 30, then times 40. Having it this way, I know that I can see that I have x here and I have another x here, and there is multiplication between them. Actually, this is going to result into x squared. Of course, I have y also here. There's 4y here, there's another y here. If I multiply that together, I'm going to have y squared. Likewise, the same thing, if I have z here, then I also have z here. If I can have z on two bases here, definitely if I multiply that together, it's going to give me z squared. Therefore, I have x squared multiplied by y squared, then multiplied by z squared. Yeah, still equal to the same thing that I have at the right hand side here, which is still the same thing, 20 multiplied by 30, then multiplied by 40. However, I'm going to proceed to step number 2, which states that I'm going to use an index rule. And what does the rule say? If I have a times b times c, and all are raised to the same thing, that is m, put this in parentheses, then this is going to be equal to a b, c, a, all under parentheses, then raised to the power of m. If I should apply the same thing to this left hand side here, what am I going to have? I have x, y, z, all in parentheses, then raised to the power of 2. And at the same time, I'm going to multiply 20 times 30 times 40, and this is going to be 2 times 3 times 4, that is 24, then 0, 0, 0, that is going to be 24,000. 24,000 here. Having this, the next thing we're going to do is to remove this power of 2. Remove the power of 2. The power of 2. So, how am I going to achieve that? Yeah, I can do this by multiplying these 2 by its inverse. It's going to remove that. The inverse of 2 is 1 over 2. That is multiplied by 1 over 2. Of course, it's going to remove that. Then the next thing is I have to multiply the right hand side also by the power of half. So if I do, I have, because it's already 1 there, raised to the power of 1, 24,000 raised to the power of 1, then multiply by half, I have 1 over 2. And this is going to cancel, as we said earlier on. 2 goes here, that is 1, 2 goes here, that is 1. So the 2 is gone, the power of 2 is gone, then we still have 24,000 raised to the power of 1 over 2 at the right hand side. And remember that when we have a raised to the power of half, it's just the same thing when we say square root of a. Therefore, what we're going to have left is x, y, z equals to square root of 24,000. Yeah. What we're going to do now is to this right hand side, we're going to break it into its prime multiple factors. So by so doing, we'll be able to break down this 24,000. So let's quickly break down here 24,000. If we start by saying 2, any of these two are going to get, that's going to be 12,000. Then at the same time, we continue with 2. We have 6,000 here. Then we continue with this same 2. We have 3,000 here. We still continue with this 2. We have 1500. Let's continue with these 2 here. What are we going to have? We have 750 here. Continue with these 2. What are we going to have? 375. 375. This time around, we're going to try with 3. Say 3 here. Then we have 125. 125. Then we're going to continue with 5. 5 here. That is going to be 25. Then with another 5. We have 5 here. Then with another 5. So we have 5 inside. 5 in 1. In 5, that's going to be 1. We can see that we have 1, 2, 3, 4, 5, 6. That is 2 raised to the power of 6 multiplied by. Then we have 3 and 5 here, which is 15. Then we have the last one, which is 5 multiplied by 5, and that is 25. Of course, this is equal to 24,000. And 2 raised to the power of 6 is actually 64. Multiplied by 15, then multiplied by 25 equals to 24,000. And we're going to need this instead of 24,000. This is what we're going to use. Therefore, my xyz is now equals to, that is 64 multiplied by 15, then multiplied by 25. And according to sort, I'm going to break this down. That is, we have square root of 64 in a separate, then we have square root of 15 in a separate, then we have square root of 25. Actually, this is 8 multiplied by square root of 15, then multiplied by 5. At the end of the day, 8 multiplied by 5, that's going to be 40. 40, then root of 15 left. And this is xyz. xyz. Actually, that is not the final answer. This is just the combination of xyz. I'm still going to need to know what actually is the value of x, what is the value of y, and what is the value of z. This is what I'm going to call step number 4 now. And what am I going to do? I'm going to equate equation 1, 2, 3. 1, 2, and 3. 2, that is 40 root 15. So I'm going to say from equation 1. You still remember what equation 1 is? That is from the beginning, xy equals to 20, that is equation 1. So I'm writing xy equals to 20. That from what we've gotten here, xyz is 40 root 15. xyz equals to 40 root 15. Since I already know that xy is 20 and that is saying xy is present here, so which means xy here is just 20. So I'm going to write up clearly and say 20z just equals to 40 root 15. Of course, to know the value of z only, go to divide both sides by 20. 20, then divide by 30. Of course, this is going to go for this. Then we have 30 here, 1, 30 here, 2. Therefore, at the end of the day, the value of my z is now equal to 2 into root 15. Also from equation 2. Equation 2. Still remember what equation 2 says. That is yz equals to 30. That is equation 2. Yz equals to 30. Yz equals to 30. And at the same time, we should still remember that xyz equals to 40 root 15. And to know, we have to write that xyz equals to 40 root 15. And what we need to know also, if yz is 30 and I have the same yz here, which means I have 30 here already. So I should say x multiplied by 30 equals to 40 root 15. Therefore, from here on, to get the value of my x, I'm going to divide both sides by 30. 30, then this side 30. Of course, this is 1. Then 0 cancel 0 here. I have 4 over 3. That is 4 root 15 over 3. Therefore, my x is now equals to 4 into root 15 over 3. I've gotten the value of my x. I have also gotten the value of my z. Then I'm left with y. So I'm saying from equation 3, I have xz equals to 40. Remember from the question, that is equation 3 as it is in the question here. Xz equals to 40, equation 3. We're still going to say xyz equals to 40 root 15 as we got it from the previous page. That is from here, xyz is equal to 40 root 15. In that case, xz, that is 40, and I have xz here, which is equal to 40, except y that I don't know. So I'm going to say 40y equals to 40 root 15. In order to get the value of my y here, I'm going to need to divide both sides by the same 40 divided by 40. Actually, this 40 over 40 is gone. So I have, and at the same time, 40 over 40 here is also gone. So I have my y equals to root of 15. Y equals to root of 15. So that is the value of my y. And don't forget, this is the value of my x. And at the same time, this is the value of my z. But don't forget what the question says. Actually, the question says I'm going to find x squared. That is, wherever the value of x, I'm going to square that plus wherever the value of y. Then I'm going to subtract z from that. So whatever I get is going to be my final answer. So I haven't gotten the final answer. So I'm going to go ahead and do that. Therefore, bringing all the values together. So x squared, that is, x is 4 root 50 over 3. 4 root 50 over 3 square. This is going to be squared. Then plus y. What's the value of y? That's going to be root 15. That is root 15. Then minus z. What is z? Z is 2 root 15. Actually, this power is going to affect this root of 15. It's going to affect this 4. And at the same time, it's going to affect this 3. Because when we have a times b all in bracket raised to the power of n, it is going to be written as a raised to the power of m multiplied by b raised to the power of m. Then at the same time, if we have a over b raised to the power of m, so it's going to affect both of them. That is a raised to the power of m over b raised to the power of m. That is why the same thing will be applied to whatever we have in the parentheses here. That is 4 square, the root of 15 all square over 3 square plus root of 15 minus 2 root of 15. 4 square, that is 16. 3 square, that is 9. 15 square is going to cancel the square root, so we have 15 left. 16 multiplied by 15 over 9 plus root of 15, then minus 2 root 15. 3 goes there, that's going to be 3. 3 goes there, that's going to be 5. 16 times 5, that is 80 over 3, then plus root of 15, then minus 2 root 15. And this is final answer for the question. And this is final answer for the question. Wait a moment, we might need to verify if this value of x, y, z are actually correct. And don't forget to do this to help this channel grow. To confirm this, actually, we're going to see from the question if the left hand side is just going to be equal to the right hand side. If it is, then it shows that the value of x, y, z that we've gotten are just correct. Therefore, here, the value of x we have here is 4 root 50 over 3. So let's put that there. That is 4 root 50 over 3. That is x. Then y. Y is, that is x multiplied by y is equal to 20. Y is root 15. So multiply by root 15. We're going to see if this is just going to be equal to, if this is going to be equal to 20. Let's say this is root 15 over 1. Therefore, root 15 times root 15, that's going to be 15. Then times 4. That is, we're going to have 4 multiplied by 15. Multiplying two roots together of the same thing is going to remove the roots. So this all over 3. So we're going to say 3 goes there, that is 1. 3 goes there, that is 5. That is then 5. At the end of the day, 4 multiplied by 5, that is going to give us 20. That shows that this left hand side is 20, which is equal to 20 at the same time. Then for the equation 2, let's see if yz is actually 30. We go to the value of y, which is root 15. We have root 15 there. Then and at the same time, z, what's the value of z? Multiplied by, and that is 2 root 15. We have 2 root 15 here. And if we multiply this together, root 15 times root 15, that's going to give us 15. Then times 2, that is 2 multiplied by 15. And this is equal to 30. As it is, so 30 is equal to 30. So that is correct also. Also, to equation 3, which we have xz equals to 40. So what's the value of x here? And that is 4 root 15 over 3. Then that is x. Then what is the value of z? That is 2 root 15. So multiply by 2 root 15. This is fraction. Then we make this fraction looking also by saying over 1. Then we're going to say 4 multiplied by 2, that is 8. Then root 15 multiplied by root 15, and that is 15. So we have 8 multiplied by 15. Exactly as I am writing 8. 8 times 15. Then we have 3 times 1, that is over 3. Then 3 goes there, that's going to be 1. 3 goes there, that's going to be 5. Actually, what we have left is 8 times 5, and which is equals to 40. This has proven that xz is 40, which is also equal to 40 as we have it here. And this have shown that the value of x is correct, the value of y is correct, then the value of z is also correct. Please and please, if you really love my explanation, please subscribe to the channel. If there is something to add that is omitted, put that in the comment section. I'm going to read that and I'm going to love that.